Now we'll see what is the post request. Data is included in the body of the request. It should be used for any action that has side effect. It is for storing, updating data, ordering a product. Now post request is used for that. This is an example of a post request. Same way, post http my site kg search.php. If you see the one highlighted in green, you will see accept text or XML, application XML, XHTML, image also is accepted. So this is how post request is sent, and then finally you can see category ID equal to 1, which we had shown you in the get request also. Now get versus post security. The information contained in the parameters can tell a user a lot about how your application works. The get parameters are easily visible in the address bar. Post parameters are hidden from the average user. Users can still view the source code. Users can still view the packet. Users can still intercept and modify web requests. Now to give you an example, can you post or can you use the guest request to send your username and password? This is another beautiful quote, Weinberg's second law. If builders built buildings the way programmers wrote programs, then the first woodpecker that came along would destroy civilization. So I think that sums it up beautifully. Take a moment, read this statement, and you will realize what Weinberg is trying to say. Why web application vulnerabilities occur? So we call it the web application security gap. Security professionals don't know the applications. Application developers and QA professionals do not know security. Now, when you see on the left side, as a network security professional, I don't know how my company's web applications are supposed to work. So I deploy a protective solution. But I don't know if it's protecting or it is doing what it is supposed to do. Now, from the application developer's perspective, as an application developer, I can build great features and functions while meeting the deadlines, but I don't know how to develop my web application with security as a feature. Now, this is the security gap which is actually prevalent in the industry. There is a lack of awareness of application vulnerabilities in the security departments. Security departments scrutinize the desktops, the network, and even the web servers, but the web application always escapes their measure. Even in departments that want to audit the web application vulnerabilities, the lack of effective tools has made it impractical. So as a result, certification and accreditation programs rarely examine the web application. In fact, the entire development cycle is usually missing from the security procedures and control. This illustrates the fundamental gap between security and development, which creates these web applications or which gives rise to these web application vulnerabilities. Now, many traditional information security practitioners are ill-equipped to mitigate application security issues. Why? Why that statement is made? Because they have little or no experience in coding. They have no experience coding in modern enterprise environments like say .NET or J2EE. They understand that there are risks, but they are not in a position to address them. Now, if you take the specific environment or scenario in the Indian context, many of the security professionals, barring the ones that have come out of engineering or master of science in cyber laws or information security, most of them traditionally were chartered accountants or finance personnel who have additionally qualified as information security auditors. Many of them are highly knowledgeable in your IT systems, but again, many of them do not understand the intricacies of how the technology works. That's where the gap also arises. So it becomes important that the person doing the information security audit of a web application or a web application assessment be at least technically competent. He need not be an expert in J2EE or .NET or Apache or PHP, but at least has the ability to understand how the program works, how the programming works, and where to look for flaws or where to look for potential vulnerabilities in coding. That's the most important point. So it is not that a person has to be an expert. A information security professional itself has to be a multitasking professional or multi-knowledgeable professional, for the simple reason that one day he will be doing a network audit, so he should know about how network work. Another day he will be doing a web app audit. The third day he will be doing an audit based on PCI DSS or ISO 27001 or COBIT for that matter. So, information security professional should be up to date with the technologies, with what is going on in the market, about new products. Suddenly, if he tells, now I have a web application firewall. Now audit the web application firewall and tell me where the configuration has gone wrong. So that's where the information security professional has to keep abreast with the latest technologies, the latest market developments, and the needs and requirements of the client organization should be understood. The auditor should be able to fulfill it. Being overly technical is also an issue because you have to balance between the technical and administrative aspect. As we have discussed in domain 2 also, there should be a balance between administrative and technical measures. Everything can't be technical, everything can't be administrative. There should be a balance. So in my experience, what I have found is a person who is extremely good technically lacks communication skills, because he is very good at working in the system and getting results. So he does not know, even though he does his job properly, he does not know how to communicate to the client. Or you take the other way, a person who is not at all proficient in IT, he does an audit, he knows how to communicate, but he doesn't know where the problems are. So there should be a balance between what is required for the organization and how you present the findings to the organization. Now, if there are a lot of vulnerabilities in the organization, I can go to the organization and say, sir, you are sitting on a volcano. That sums up the entire process. So it can erupt anytime, meaning your systems can fail anytime. You will be hacked anytime. But is that the way to put to an organization? No. So the right amount or the right tone should be conveyed to the organization. So there should always be a balance between the administrative and technical measures. And even in web application, everything is not technical. There are some aspects you will have to do manually so that the organization realizes the importance of the work that you have done and will go on further process to secure the system. Again, we will see the web application vulnerabilities. There are two categories here, technical and logical vulnerabilities. Technical vulnerabilities are a result of insecure programming techniques. Mitigation will require code change. It is detectable by scanners. Example is HTTP example / order.asp question mark item equal to there is a script alert or XSS is being tried there. Logical vulnerabilities, result of insecure program logic. So you see the subtle difference between the technical and logical. First is result of insecure programming techniques. Second, under logical it is result of insecure program logic, most often due to poor decisions regarding trust. Mitigation often requires design or architectural change, so it is much more dangerous, so it requires a lot of time to be corrected. Detection often requires human to understand the context. Now example order.asp item equal to toaster and price equal to 30. Now to change this, it is a logical vulnerability. You need to do design change for it to go properly. Second, the importance of securing the web application also has to be enlightened to the customer. The customer should realize that there are serious vulnerabilities and it needs to be addressed. Two, They have to make sure that their development team understands the problem and rectifies the problem as quickly as possible, because again there will be reputational loss, there will be loss of money if some financial transaction is going on. So there could be so many other issues. So the organizations should perceive security as an important component in their design overall business objective. You take the example of say Snapdeal or Flipkart or Myntra.com. They do online transactions, right? So there's a lot of hits on the site, a lot of financial transactions that can go on, pay through credit card, pay through debit card, pay through PayPal, whatever it is. So they imagine a situation if if Flipkart or Snapdeal or any other online company is compromised. Imagine the loss of data, the loss of reputation for them. So they make sure, I know for a fact because Flipkart is very close to my office. There is a very large security team sitting in Flipkart who constantly monitor, who constantly test the applications to ensure that new vulnerabilities do not come. The same is the case with banking applications. They have to be doubly sure that the developer maintains proper coding standards, otherwise there could be a loss of data. The same is the case with insurance industry, where customer data is of immense importance. You cannot afford to lose a customer's data because it's a loss of privacy. There could be other implications also. Or in a manufacturing unit, there could be a problem. So you can have many examples of how these vulnerabilities will come up and why these insecure program logic and insecure program techniques are happening. Now if you see here, web application vulnerabilities occur in multiple areas. The first is platform. It is known vulnerabilities are there. Then extension checking, common file checks, backup checking, directory enumeration, path truncation, hidden web paths, forceful browsing. It comes under what category? The web server. The web server itself is subjected to a variety of known vulnerabilities, all of which must be readily patched for. The right side, the blue one, is for the web applications, where application mapping, cookie manipulation, custom scripting, parameter manipulation, reverse directory traversal, brute force, application mapping, cookie poisoning or cookie theft, buffer overflows, SQL injection, cross-site scripting. Now the actual administration and management of the content and the server is very important, because a poorly or misconfigured server can permit system or source code disclosure. Maybe a file in the system can get disclosed or lost or altered, or the source code disclosure itself may happen. The application itself is of utmost importance. It also can be inadvertently reveal the source code and system files, and in some cases allow full system access also. It can mistakenly allow replay attacks against your customers. It could allow a hacker to impersonate the customers. In addition, it is the web application that interacts with the database to manage and track customers' information and store business and transaction information. So one slip up in the web application can expose the entire system and the database right through the web browser, right over port 80. So it's very dangerous. Now when we look at platform known vulnerabilities can be exploited immediately with a minimum amount of skill or experience, like the ones done by script kiddies. It is most easily defendable of all the web vulnerabilities, and it must have a streamlined patching process. Known vulnerabilities in the web server are obviously a great source of risk. The difficulty becomes installing patch on a lot of servers. Then there must be a streamlined patching procedure, meaning you test a patch, you see the impact of the patch on the application. If everything is okay, then you migrate it to the production environment. Then you need to take a downtime in some cases because web servers are meant to be run throughout day and night 24 bar 7 without being switched off. So whether you have downtime to do that, then you must be easily able to inventory or identify your servers for patches. Now if you miss all this, you don't have to worry, because if you miss a patch, then a hacker will let you know that you have missed the patch. Then there are administrative issues which are less easily corrected than known issues. It requires increased awareness. It is more than just a configuration, must be aware of security flaws in the actual content. Remnant files can reveal applications and versions in use. Backup files can reveal source code and database connection strings. Now, administrative issues are less easily corrected. What is it means? It's not as easy to fix administration issues. It requires a proper security awareness from those who manage the website and its content on a daily basis. So people who are doing that on a daily basis should have proper awareness. Obviously, you don't want directory browsing enabled anywhere, and you want the right access control list to be implemented. It is more than just the configuration itself. You must be aware of the implication of the content as well. Now, for example, remnant files like readme.txt or sample application can reveal the applications and the versions in use. Commercial applications have known vulnerabilities also, not just the web servers and operating system. Backup files or improper application mapping can also reveal source code, including the information necessary to connect to a database. Now, a lot of tools which do the web application testing, like your IBM AppScan commercial version, Acunetics commercial, there is Core Impact, there is HP Web Inspect. So there are Qualys, which is again service-based model. Now all of this report backup files, but nobody really gives importance to what that backup file means. So in this context, when you see, now the backup files can reveal the source code if that backup file contains a source code or some critical information. It could be news or it could be party time for the hacker. Now again, when we come to application programming, the common coding techniques do not necessarily include security. Input is assumed to be valid, but it is not tested. Like I said a few slides ago, unexamined input from a browser can inject scripts into a page for replay against later visitors. Unhandled error messages reveal application and database structures. Unchecked database calls can be piggybacked with the hacker's own database call, giving direct access to business data through a web server. Now, the application logic itself must be carefully constructed and must include security mechanism. So, you should never assume that the input that you received is what you have expected. It must be tested, it must be validated, and then it must be filtered. A simple thing is test before you ingest. And you have to be very careful on how you call up the files, especially if you pull files directly from the file system. You could expose your page's source code, or even worse, you can expose system files, which could be very dangerous. So you have to be particularly careful to remove anything that even resembles a JavaScript or a VB script. Inadvertently storing scripts entered from a hacker will allow them to be replaced against your customer, resulting in your website attacking your customers, or divulging session information to the hacker. And then you have to handle all error messages properly. Unhandled messages or raw error messages are a roadmap through the application and the database. Another important thing is structure your database calls carefully and then scrutinize any user input that will become used or that will be used in the query. So carefully constructed input could allow a hacker to piggyback your queries